Hello, this is John from caveofprogramming.com. I'm actually remaking this particular video quite a long time after I finished the course, because rather embarrassingly I managed to create an awful bug in the last version of this code that I wrote, which I traced to this particular method. So what I'm going to do now is to make absolutely sure I don't do anything stupid, or as sure as possible. Rather than type this out in front of you, I'm going to just talk you through my corrected code here so you can see how it works. So what we basically need to do is we need to figure out which range a given pixel is in. So for a particular pixel we apply our algorithm and it gives us a number of iterations, and the iterations we've set somewhere to be equal to 1000 here in Mandelbrot.h. Then in main.cpp we specify the colouring for different ranges, for different number of iterations of pixels. So these we've specified as floating point numbers, but they're going to get multiplied by that number of iterations. So we're saying that if a pixel has a number of iterations from 0 to 300, then it's in the first range, which we could give an index of 0. If it's from 300 to 500, it's in the second range, index 1. And if it's from 500 to 1000, it's in the third range with index 2. So it's like a zero-based range number that we actually want. So it doesn't matter too much whether we consider a pixel with 300 iterations to be in the very first range or at the beginning of the second. That doesn't really matter, as long as we can, basically get this right for our pixels. So what we need is a function which we could call getRange, and we're going to pass that function a number of iterations, and we want that function to tell us which of these ranges that pixel will be in for that number of iterations. So if we pass it 200, it should say 0 for the first range. If we pass it let's say 520, it should say 2, which is for the third range here. So that's range with index 0, and that's what we want to return from our getRange function that we're going to create. This is range index 1, this is range index 2. So first we need to go to fractalcreator.h and add a prototype for the method. It's going to return an int, which is 0, 1 or 2 in this particular case, and it's going to accept an int which is a number of iterations. I've called it getRange and I made it const because it doesn't modify any of the member variables of Fractal Creator, so we can say it's const, it doesn't change anything, and that will help make sure that we don't accidentally modify any variables there. And then in fractalcreator.cpp I can go in and add that method which I've got here. So I'll explain a bit about how this works. So if you want, you can pause the video and have a go at implementing that yourself. It's a nice sort of fairly self-contained problem. We just need to translate a number of iterations to an index 0, 1 or 2, which is, you can think of like an index, into m_ranges. Well, you could sort of think of it like that, because that is how we're ultimately going to be using it. Okay. So let's have a look at this. So the first thing I did was create a range variable which I've initialized to 0, although I actually found it easier if I first calculate the range with a 1 based index, so the ranges will be 1, 2 or 3, and then subtract 1 from it after I've done that. So it's never actually going to be 0 after it gets out of this loop, or it shouldn't be. I'm just initializing variables because I think it's a good habit to help reduce bugs. And then I'm iterating from 1 up to 1 less than the size of this ranges vector that we're adding to ultimately with this add range function. So if we look at add range, wherever that is, let's search for it, add, or I could just use the Project Explorer. So when we add a range, we end up adding to this m_ranges here. Okay, so I'm iterating from 1 to 1 less than the size of the ranges vector. And then what I do is I set the range variable immediately equal to I. So if we only do one iteration of this loop, it's going to be set to 1. And then we say, okay, is the end of this range, is it greater than the number of iterations? So we're specifying ranges by specifying the end of them, basically, except for the very first one. And if it is, that means I is in that range. So if we look at this, so it's like, for example, if we have a number of iterations equal to 200, we start looping through this and we say, is 0 greater than, well, we actually don't check the first one at all because we're starting at 1 here. So the first thing we do is say, is 300 greater than 200? And yes, it is. So we break the loop and we leave our range variable set at 1 to say that it's in this range using a 1-based index. If 300 isn't greater than the number of iterations, let's say we've got a number of iterations equal to 700, then first we check, is 300 greater than 700? No. And at that point, we're setting range equal to 1. Then we say, is 500 greater than our number of iterations? Did I say 700 there? I think I did. So in that case, if we have 700, the answer is still no. So we're setting I equal to 2 now. And then we're doing another loop and we're saying, is 1000 greater than 700? And yes, it is. So in that case, we would assign I the value 3 at that point. Okay. So then finally we subtract 1 from I to get a 0-based index. So I hope that explanation doesn't confuse you horribly. You can always download my code and take a look at it and think about it. It's a simple problem in essence. It did take me a bit of thinking to get my head around this and figure out how best to do it. Now, a couple of things just one thing really that you can do just to be doubly sure about this, because if you don't get this right, if you start getting values for I that, let's say, are equal to ranges.size, you'll end up trying to read off the end of vectors or arrays. And that's not good because, as I discovered, I already knew this unfortunately, but I didn't pay enough attention to it. If you do try to access something in an array that's off the end of it with a bad index, often your C++ program will seem to work, but occasionally it's going to fall over. And I only found out about this because I'm ashamed to say one of my subscribers actually very kindly told me about it. I think his Visual C++ was warning about it. So what you can do to double check that a little bit, firstly you can use this assert function. So if you include assert.h, then you can type assert and conditions that must be true. And if you run your program in debug mode and the condition you've entered here is actually false, then it will crash with an error message, which is very helpful for checking what's going on. So here I'm saying assert range is greater than -1, because the range has got to be at least 0 here. And then I'm saying assert range is less than m_ranges.size, because if we're going to use range as an index into arrays like m_ranges, then we don't want it to ever be actually equal to the size, because that would be an index off the end of the vector or the array. So we can put these two asserts in, and at least those will help a bit with making sure that I doesn't go outside the range that it should do when we run the program. And then it's also a good idea to test this a little bit. Let's go to main.cpp. So we could check this out after we've added the ranges, which is very important. We could say cout get range and pass in some value. Like let's try 200, and we expect 200 to be in range 0. Let's try this and run it. Oh yeah, we need to say, of course, fractal creator dot get range. Let's save that, build it, and run it. And there's a problem there actually. Let's check this out. So is a private member. Yeah, what I should do, just temporarily for debugging, I'm going to make it public. So we do want it to be private, but just so I can check this out, I'm going to make it public. Save that, build it, run it, and check. And we've got 0. So that is what we expected, because 200 is in this first range. So if we use the zero-based index, that's index 0. Let's try 310. So that's got to be in range 1. So we try this, and you get the idea, basically. So that's in range 1. And we should find that, let's say, 999, that should be in the final range, which should have an index of 2 if it's zero-based. So we run this, and it is 2. So as far as I can tell here, it's looking really good now, finally. So it's definitely worth checking that. If you were working on something like financial software, you'd have to be very picky about where your ranges start and end. You know, is 300, is that going to be in the 0th range or the range with index 1, for example? You'd have to think about that and test those edge cases very thoroughly. But fortunately, this isn't financial software, and here it just doesn't really matter whether 300 is in this range or the next one. Okay, that's it for this tutorial. Apologies to anyone who saw the first version that was incorrect. I'd managed to produce values of I that went off the end of the range. But anyway, okay, so until next time, happy coding.